In this problem, it says find all extrema of g of x equals secant of x on the closed interval negative pi over 6 to pi over 3. So since it's a closed interval, we're going to find our absolute max and min. And so it's going to start with us finding the derivative. And the derivative of secant of x is secant x tangent x. And so if I'm going to find critical values, I've got to find where the derivative equals 0 or is undefined. So in order for me to do that, I'm going to try to change the way this is written so that it's an easier function to solve. So secant of x is 1 over cosine of x, and tangent is sine of x over cosine of x. So when I multiply this out, I get sine of x over cosine squared of x. So now I have a quotient. And so it's really easy to see at this point that where sine of x equals 0, the derivative will be 0. Where cosine squared of x is 0, the derivative will be undefined. I'm going to pull those out separately and solve them separately. Sine is 0 on intervals of pi. So x would equal 0, pi, 2 pi, and so on. And then cosine squared of x would equal 0, where cosine of x is 0. So cosine of x is 0, cosine squared of x equals 0 at intervals of pi over 2. So pi over 2, 3 pi over 2, etc. So we have a closed interval. We're only going to pick critical values that are on our closed interval. And our closed interval is negative pi over 6 to pi over 3. Well, 0 is definitely between those. Pi is not because it's greater than pi over 3. Pi over 2 is greater than pi over 3. So this is the only critical value that I'm going to have on that interval. So that's one of my test points, and then I'm going to use my endpoints to test as well for absolute max and min. And it's absolute, so I'm going to go to my original and plug in all of my test points. So g of 0, my critical value, g of my left endpoint, and g of my right endpoint. And so if I look at my function secant of x, it's 1 over cosine of x. So when I plug these in, I'm going to plug them in that way because I'm more familiar with the values for cosine. So 1 over cosine of 0, 1 over cosine of negative pi over 6, and 1 over cosine of pi over 3. Okay. So cosine of 0 would be the value equal to 1. So that's just 1 over 1, which equals 1. Cosine of negative pi over 6. Well, negative pi over 6 is going this direction around the unit circle, so it corresponds here. The other way to think of it is pi over 6 with your hand is this finger. And it's negative pi over 6, so that's the fourth quadrant. X's are still positive in the fourth quadrant, so it would just be square root of 3 over 2. So 1 over square root of 3 over 2. Because pi over 6 is this angle, there's 3 fingers, cosine's the fingers on top, so square root of 3 over 2. And then if you have a fraction in the denominator, it's the same as multiplying by the reciprocal, so this is equal to 2 over square root of 3. And then my last one, which would be cosine of pi over 3. Well, if I'm using my hand trick, pi over 3 is this finger. So cosine would be the number of fingers on top. So it would be square root of 1 over 2, which is just 1 over 2. So this would be equal to 1 over 1 over 2. And again, dividing by 1/2 is the same thing as multiplying by 2 over 1. So that would just make this equal to 2. Now, this is a value that I'm not as familiar with. So I need to figure out, is it greater than 1? Is it less than 1? Is it greater than 2 or less than 2? So one thing I know for sure is that 2 divided by square root of 3 is between 2 divided by square root of 1 and 2 divided by square root of 4. Square root of 1 is 1, so 2 divided by 1 is 2. Square root of 4 is 2. 2 divided by 2 is 1. So this value is between 1 and 2. Therefore, it is not an absolute max or min. So my absolute max is at the point pi over 3, 2. And my absolute min is at 0, 1.